Okay, so for both of these, we're simplifying. I could have also just said reduce the fractions. These do not, neither one of these divide out. So we're going to be just reducing the fractions. So we'll start out by reducing the numbers first. So here we've got 35 over 14. Both of those can be divided by what number? 7. So what's 35 divided by 7? 5. And 14 divided by 7 is 2. Do we change that into 2.5? No. Remember, we mentioned that on Monday, that when we have an algebraic fraction, a fraction with variables in it, we never turn it into a mixed number. It always stays as a fraction, even if it's improper like this. The reason for that is we still have those variables there, and we don't know what value those variables have. So we're not sure whether it's an improper fraction or not. Now then we have the variables, and we take each variable separately, and we have two things we have to figure out for each of them. The first thing we have to figure out is that variable going to end up in the numerator or the denominator? Is it on top or bottom? So x will be on top. The reason we know it's on top is the larger power is on top in the original fraction. Now, how do we figure out what the power is going to be? 8 minus 3. Very good. We subtract. 8 minus 3 is 5. So that's x to the 5th. So then we have to do the same for y. Is y going to end up on top or bottom? Bottom. And with a power of 2. 5 minus 3 is 2. Any questions on that one? Okay, well then over here we do the same thing. We can take out the numbers and reduce the numbers. 27 over 36, both of those can be divided by what number? 9. 27 divided by 9 is 3. 36 divided by 9? 4. Very good. So starting out up here, we've got 3 over 4. Now for the variable, x is going to end up where? Bottom, because the larger power is the 4 and it's on bottom. It's going to have a power of 1, or just it's going to just be x. 4 minus 3 is 1, so it's x to the 1, or just x. Y is going to end up where? On top, because the larger power was on top. And it's going to have a power of 6. Good. 11 minus 5 is 6. What's going to happen to z? Same power. 8 minus 8 is 0, or z to the 8th over z to the 8th cancels out. So the z is gone. So we have 3y to the 6th over 4x. Any questions there? Okay. The main reason we deal with the variables and the fractions, it's not because I expect you to see a whole lot of fractions with variables in them once you leave here, but it forces you to think about what is the actual process of what's going on. We are actually canceling out those factors to reduce the fraction. All right, well, our main topic for today is we're going to start talking about ratios. A ratio is a comparison between two numbers. So for example, if I look around the room, we have 8 students in here right now, and there are 4 that are gone. So I could look at a ratio of missing students to students present. There's 4 that are gone, and there are 8 students here. I could write it like that as a fraction, 4 to 8. I can write it with a colon in it like this, 4 to 8. Or I can actually write it, in this case, I could write it with the word 2 in it, 4 to 8. I prefer to write it in fraction form because there are a lot of things that we can do with our ratio that are similar to things that we do with a fraction. For example, both 4 and 8 can be divided by 4. 4 divided by 4 is 1, 8 divided by 4 is 2. So that reduces to a 1 to 2 ratio. Now I could do the same thing here in any of these other forms. I mean, I could divide both of those out to get 1 to 2. It's just I'm used to doing it with fractions like that, so it looks similar to me. Now I said in this case it would be written as 4 to 8. And the reason I said that is there are two types of ratios. This ratio here compares part A to part B. I divided this group, which is the class, into two subgroups. The students that are not here and the students that are here. The other way I could go, the other type of ratio that's out there is part A to the whole thing. Now, if there's 4 students here, or 4 students missing and 8 students here, that would mean that there are how many total students? 12. So what I could say is, instead of 4 students to 8 students, I could say 4 out of 12 students are missing. And in a lot of the ratios we do, we have that option. We can change it over. In the medical fields, we have something called a dilution. And a dilution is out of the whole thing. If we say that you have a 1 in 6 dilution. A dilution is taking a medication and putting it into an inactive solution. The medical abbreviation is NS. That can stand for several things: normal, saline, neutral solution. Basically what it is it's sterile water. It has no medicinal value. Its only purpose is to dilute out the medication to make it easier to get it into the patient. So a 1 in 6 dilution is saying 1 part medication to 6 parts of total solution. Now that's not 1 part medication to 6 parts water, it's 1 part medication to 6 parts total. So it's the ratio of medication to total. If I want the ratio of medication to water, well, there's still only 1 part of medication. How many parts of water are there? There's 6 parts total and 1 part's medication. 5. 6 minus 1. So you can see there's the ratio of medication to water is 1 to 5. Ratio of medication to total solution is 1 to 6. And we could actually put in the ratio of water to total solution. It would be 5 to 6. So often within a single ratio, there are actually a total of 3 ratios. The one is the one we're given. The other 2 are implied that we can find from that ratio. Now, other ratios, let's say we look at these tables here. We might have a length to width ratio. Well, the length of these tables, they're 6 feet, so they're 72 inches. The width is 18 inches on these tables. So the inches cancel out. Both 72 and 18 can be divided by 18. 72 divided by 18 is 4. 18 divided by 18 is 1. 4 to 1. Now here is one place where these ratios differ from fractions. If this were just a fraction, I would make that just 4. But as a ratio, we have to leave it as 4 over 1, because remember, a ratio has to compare 2 numbers. So I have to have both numbers there. I can't just reduce that to 4, because then there's not a second number there that's being compared to. The other thing you'll notice is in all the ratios I've discussed so far, I've compared the same units. Here, I made that inches to inches. The units have to cancel out in a ratio. Up here, it was parts to parts. Up here it was students to students. In a ratio, both the two numbers have to compare two things that have the same label or the same units. So if I have like 2 feet compared to 18 inches, that's not a ratio. But I can turn it into a ratio because 2 feet can be turned into 24 inches. And now it's a ratio because I'm comparing two things with the same units. So now the units will cancel out, inches will cancel out. Both of those can be divided by 6. 24 divided by 6 is 4. 18 divided by 6 is 3. So that's a 4:3 ratio. Now here's another difference between ratios and fractions. If this were a fraction, I would change that into a mixed number of 1 1/3. But remember, this is not really a fraction. It is a ratio. And a ratio, again, is that comparison of two numbers. So I will leave it as an improper fraction. It is 4:3, not 1 1/3. So you asked about, does it have to compare two things that have the same label? Do the labels have to cancel out? And for a ratio, they do. So what if we have something where the labels don't cancel out? Let's say we send you on a road trip, and you drive 365 miles in 7 hours. There is no way to convert miles into hours or hours into miles. So this is not a ratio because the units cannot be made into the same unit. So this is what is referred to as a rate. That is the first big difference between a rate and a ratio. A rate compares two things with different labels. A ratio compares two things that have the same label or same units. The second big difference between a rate and a ratio. Our ratios here were often left like this, is 4:3. Now this one here is 4:1, which we'll talk about in a second, or 5:6.
And they don't normally keep them like looking like fractions, right? Don't they put like the
Do the colon or the word to or whatever. Like here, the dilution is 1 in 6 or 1 out of 6. So that's telling you that it's the 6 is a total and not just the other part.
so do you think like when math lab is going to want you to put it in a fraction?
It'll show the answer. When it gives you the answer, it'll either show the colon or it'll show you what form it wants it in. If it doesn't give you any form, put it into a fraction. Now here, this ratio, 4:3, the denominator is a 3. There is something called a unit ratio. In a unit ratio, the denominator is 1. So if I wanted to convert this, and like I said, normally we would leave this as just 4:3. But if I wanted to convert it into a unit ratio, I would divide out the denominator. I'd divide by 3. 3 divided by 3 is 1. 4 divided by 3 is 1 1/3. So that unit ratio would be 1 1/3 to 1. Now that's kind of awkward with the ratio. So a ratio typically would leave it as 4:3. A rate, however, is almost always converted into what we call a unit rate. So in the unit rate, the denominator has to be 1. We leave the labels, but we're going to divide out that number of 7. 7 hours divided by 7 is 1 hour. We have a denominator of 1. So we have to divide the numerator by that same number, the 7. 365 divided by 7 is what? 52.142857,143 approximately miles. You got to remember math, the calculation part of math is all about patterns. And once you start to see the patterns, the calculations are really simple. There's a distinct pattern there that makes that easy to do. So now this is a unit rate because the denominator is 1. You also have to remember I've been doing this pretty much every day of my life for like 20 years now. So if I wasn't good at it, I'd have flipped out a long time ago. So anyway, let's round this off to 52.14. A lot of times we don't express it like this as a fraction. We'd make it 52.14, then we hide that appearance of the fraction in the units, like miles per hour, like that. So the fraction is now hidden into the units, pushed into the units. In fact, often we'll hide the fraction appearance altogether. Let's say that on this trip you get 26 mpg. Does anybody know what mpg stands for? Miles per gallon. So that is implying a fraction. 26 mpg really means 26 miles per 1 gallon. So when you see this, you have to be thinking this, because that's the form we're going to need it in when we try to calculate with it.
So what is the one, how you figure out how many miles per gallon?
Okay.
What's that?
Well, what you can do with ratios and rates and comparisons like this, you actually get into something a little bit beyond what we're going to do today, but I'm going to mention it briefly for you. It's called dimensional analysis. So if you want to know, if you want to calculate a number and you don't know the formula for it, you can actually let the dimensions tell you. If you look at 26 mpg, and if you realize that that is 26 miles per gallon, the units here, when you write it like this, tell you exactly how to set that up. So let's say you drive that 365 miles still, and you use, oh, what do I want to use here? Let's just say, oops, miles. And let's say you use 15 gallons of gas. Well, the miles per gallon is telling you that the miles have to go on top. This isn't going to be equals because it's different numbers, but it's telling us that the 365 miles has to go on top, and the 15 gallons has to go on bottom. And we need to turn this into a 1 on bottom, so you're going to divide by 15. So that's 1 gallon. Dividing 365 by 15 is going to give us, what, 24.333? So 24 1/3 miles. So that comes out to be 24.33 mpg. Usually what you would do is you'd fill up your tank. You would fill up your tank and get your tank completely full and write down your mileage. So let's say your mileage on your car is 32,568 is what's on your odometer. And you know your tank is actually full. So you write down that number and you record it. So the next time you fill up your tank, let's say your odometer reads 32,841 is your odometer reading. And when you filled it up, oh, let's see what I want to put in here. Let's say it takes 14.2 gallons of gas. So now what you do is you have to subtract these two odometer readings. So you let 7 to, oops, I gotta subtract the other way. So I've got to subtract the 32,568 from the 32,841. So we get 273 miles. That's how far we went on 14.2 gallons. So 273 miles, 14.2 gallons. And now again, we divide out the 14.2. So that's 1 gallon on bottom. 273 divided by 14.2. What's that? 19.23. Yep. It's always interesting because a lot of your newer cars now have the mile per gallon. If you do your trip reset, they'll calculate your miles per gallon for that trip. I've compared it several times on my car where you reset the trip when you fill up the tank and you keep track of it. And it's always a few tenths off from reality. But that trip thing is actually taking instantaneous gas mileage and trying to accumulate it. It's also very temperature sensitive. When in cold weather, it's way further off than it is in warm weather. Most of them are calibrated, I believe, at 72 degrees. Really calibrated to work at. Okay, so let's take a look at some common rates and ratios. Since we're dealing with rates right now, we'll stick with rates. We saw miles per gallon and miles per hour. One that many of you will probably deal with. Let's say you get your paycheck. You get $560 for 40 hours of work. That's before taxes. This is gross, yes. Before taxes. Well, let's take a look. $560 to 40 hours. Again, we want to convert it as a unit rate, so we would divide by the 40. So 40 divided by 40 is 1 hour. 560 divided by 40 is $14. So that's $14 an hour. It's not wonderful, but it's not horrible. Not worth it? Around here, $14 starting out is probably what you're going to top out. $14 an hour is about what you're going to top out at starting out in this area. 14, average starting around here is between 10 and 17, depending on what field you're in.
Coming from where I'm waitress, I mean, granted it's not consistent, but
Yep.
weekends I can average like $40, $30.
That's, I talked to a lot of students that waitress or wait and bartend, and a lot of them, even after they get degrees, they still end up doing bartending 1 or 2 nights a week or on weekends, just because, yeah, their hourly wage, because of tips, they can't match it.
How much does it go up, like not cost of living, but like
Annual raise?
going from here to like Eau Claire?
It does go up a buck and a half an hour. The difference in wage between here and Eau Claire, it is a higher wage, but it doesn't accommodate the cost of living, because you can get a 2-bedroom, 1-bath apartment around here between $400 and $500 a month. Down there, it's gonna be $650 minimum. So it doesn't make up for the difference in cost of living. Groceries are cheaper in Eau Claire, though, is the one thing.
Would it be worth it though? Like I live in Cameron, if I want to get after I get a degree to get a job in Eau Claire.
Well, if you're working it depends on what you're getting for gas mileage. Because if you're getting let's say you're getting $1.50 an hour more, well, at 8 hours, that's $12 a day more. So if your car takes 4 gallons of gas, let's say, well, at $2.50 a gallon, you're probably the cost of gas is probably taking what your difference in pay is, and then you're losing an hour and a half or 2 hours driving every day.
That's what my husband had to do. We had to work with a non-union and work in the warehouse.
Sure.
So it's like not really much help.
Well, and a lot of people forget to figure in your drive time. Let's do this. Let's say you got a 40-hour week. And you have the option of working a job that's $12 an hour. We're just going to say right next door. So, I mean, you're looking at like 0 to 5 minutes drive time, 10 minutes, whatever. Or you can get a job that pays $16 per hour with a 1-hour drive. This here, $12 per hour times 40 hours a week, of course, is $480 a week. $16 an hour times $40 a week, 40 hours a week, is $640 a week. Looks like a great deal, right? It's $160 more. Here's the things to consider. That hour's drive, and an hour's drive, you're going to use at least 2 gallons of gas. So that's going to be 4 gallons of gas per day, right? Assuming you're on a 5-day week, so that's 20 gallons per week. And we're going to assume an average. Right now it's like what, 220, 230? 230. we're going to figure an average of $2.50 per gallon. So that's $50 a week for gas. So you subtract out $50 a week for gas, you're now making $590 a week. So it's still a $110 difference. But here's the thing. You're spending an hour drive each way, so 2 hours a day on the road. So that's 10 hours a week. So this 40 hours a week is now turned into 50 hours a week. So you take your $590 that you're making for the week divided by 50 hours, and you're really only making $11.80 an hour by the time you figure in your driving. Yeah. And most people, they fail to account for that drive time. I mean, that drive time is part of your work that you're not getting paid for. Now, the question is, would you use, if you had that 10 hours a week where you didn't have to drive, would you use it to make money? Would you work a second job or whatever? You know, that's, some people say, you know what, if I didn't drive, I still am not going to work a second job, so I'm not losing anything by losing that 10 hours a week driving. So it's something you have to consider. But yeah, generally, if you have to drive an hour, you have to make at least $4 or $5 an hour or more to really make it pay off. Not to shoot down anybody's bubble. So you guys know, I actually almost exactly 2 years ago now, I used to do engineering work before I came here. I had a job offer out in Washington State, up by Vancouver. I was actually in the bay up there. It's Whidbey Island. Is a lot of naval bases and stuff out there. I was a structural engineer before I came here. And I had a job offer out there that it was a considerable, well, they offered me $152,000 a year, which is a considerable raise over what I make here. More than double, to be honest. But it would have been a pay cut by the time you figured in cost of living. Because the cost of living out there is more than double. Cost of owning it is. A house that, 3-bedroom, 2-bathroom house that on average costs $112,000 here, on the island was over $480,000. If you got off the island into the mainland of Washington State, it was still in that $340,000 to $350,000 range. So it's over 3 times as much, 3 to 4 times as much for a house there as it was comparable here. And then, of course, you get off the island into the main state. Now you're looking at an hour drive because you got to cross 2 bridges to get out to the island. So yeah, there's a lot of things like that to consider when you're looking at pay. I've seen a number of people that get trapped in, oh, this is a higher pay, I'm going to take it, but longer drive, or you have to move to an area where cost of living is more. There's a lot of stuff to consider when you're looking at that. You're maybe not writing out an equation and solving a formula, but it's the thought process is still an algebraic thought process, very much so. Yeah. Even around here from one county to the next, there's some big differences. You go east of here to Rusk County, housing is dirt cheap. Land is dirt cheap. But the job market is horrible over there. Trying to find a job over there is really tough to do. Trying to find a job that pays much more than minimum wage is really tough to do over there. Okay, so other things I might look at is dosages. Dosages are a rate. If you look at a bottle, a lot of times the dosage might be listed as 2 milligrams per kilogram per 8 hours. Well, the 8 hours is just a time frame. The rate we're looking at here is the 2 milligrams per kilogram. So if you have a patient that is, let's say we have a patient that is 40 kilograms. 40 kilograms is about 88 pounds, just for the record. So a patient that's 40 kilograms that is receiving a dosage of 120 milligrams. Their dosage is 120 milligrams per 40 kilograms. And again, we turn it into a unit rate. This is not a rate because those are different units. Or not a ratio because they're different units, so it is a rate. We turn it into a unit rate by dividing by 40. It gives us 1 kilogram on bottom. 120 divided by 40 is 3 in milligrams. So that rate is 3 milligrams per kilogram is what that patient is receiving. So let's look back at our ratios. There are a ton of ratios out there. Now, depending on what program you're looking at, some of these ratios may apply to you, some of them may not. If you look at the mechanical side of it, mechanical ratios, we're going to use our imaginations for a while because I'm going to draw pictures. And you're going to see very quickly there's a reason why I teach math and not art. Anybody want to guess what those are? There we go. We're going to look at a gear ratio. The second one I would hope would eliminate the sun. A gear ratio is the number of teeth in the driven gear compared to the number of teeth in the driving gear. Well, if we look at these, how many teeth does this big gear have? 10. In the little gear? 8. Very good. How do we know which one's which? Well, I've got to do a little more artwork. Pretend that looks like a little electric motor. So now if I separate those gears, which one's going to stop? The 8 one, the small one. That is the driven gear. It is being driven or forced to turn by the other gear. The 10-tooth gear is going to keep going. That is the driving gear. It is the one that's hooked to power. It is driving the other gear or forcing the other gear to turn. So this is an 8 to 10 gear ratio, or of course that can be reduced. Both of them can be divided by 2 to give us a 4 to 5 gear ratio. Notice in the ratio there's no units because the units divide out. It's teeth over teeth in this case. Or you could have a pulley ratio. Now pulleys, you can't count teeth, so you go off of the diameters of the pulleys. Again, you have to have a little bit more knowledge of what's going on. So pretend that looks like an electric motor. So now if I cut the belt, which pulley is going to stop turning? The 10-inch. So that's the driven pulley. The 4-inch is the driving pulley. So the inches cancel out, and both 4 and 10 can divide by 2. That's a 5 to 2 pulley ratio. So again, we don't necessarily reduce them down to a unit ratio. One last mechanical example. We'll see if I can draw this out to make it recognizable. Anybody figure it out yet? Pistons, very good. This is a compression ratio. What's that? Me playing Pictionary is very ugly. Especially if they don't let me use like symbols. Compression ratio is the expanded volume compared to the compressed volume. So the expanded volume is when the piston's at the lowest part of the stroke, so the maximum volume above the piston within the cylinder. Let's say that is 480 centimeters cubed. The compressed volume is when the piston's at the top of the stroke, so the minimum volume above the piston. Let's say that is at 60 centimeters cubed. So this is 480 over 60. So you can see again the units cancel out, they divide out. Now here, both 480 and 60 actually divide by 60. We get an 8-to-1 compression ratio. A compression ratio is one of the few ratios that actually do usually get reduced down to a unit ratio. So even if that was like 7.5 to 1 or whatever, we would put a decimal in there to get that down to a unit ratio. In construction and housing, we looked at roof slope and roof pitch. There is a difference. Slope is defined to be a rise over run. Pitch is defined to be height over span. So let's say the span of this roof is 24 feet. The height of this roof is 6 feet. So the pitch is 6 feet over 24 feet. The feet cancel out, and both the 6 and 24 divide by 6. That is a 1/4 pitch. The slope is rise over run. The 6 feet is still the rise. The run, however, is from one end of the roof, one end of the span to the peak. So that'd be half of that 24, 12 feet. So a 6 over 12, the feet cancel out. A slope is always given out of 12. It's inches of rise per foot of run, so that's why it's out of 12. So we'll just leave that as 612. I know it does reduce to 1/2. A 612 is relatively standard. A 412 is about as shallow of a roof as you'll see on a residential roof. 312 is considered the borderline between low slope and standard slope. If it's less than 312 slope, you have to have special type of roofing to avoid leaking. The A-frames, a lot of those are at least a 1212 or more. A 1212 slope is a 45-degree angle. Most of your A-frames are either 1212 or some of them are 1612 or 1812 slope. They have the really steep slopes like that. Let's see. Let's talk about medical, since we've done a lot of medical examples. You might have, like we saw, the dilution ratios. You have a 1 in 8 dilution. So again, you have 1 part of medicine to 8 parts of total solution. And we saw that there's other ratios. That's 1 part medicine to 7 parts of water or whatever. This last one I want to look at is one that most of you are going to run into at some point in your life, and a lot of people don't understand it. It's a debt to income ratio. You hear a lot of talk about credit scores and going to borrow money and worrying about your credit score. And your credit score is important, but most people don't realize a credit score usually does not determine whether you get a loan or not. The only way the credit score really affects whether you get the loan or not is if you have a really terrible credit score. If you're below like a 600 on your credit score, you're good chance you're not going to get the loan. But that really low score usually indicates that you've had problems paying back loans in the past. If you're above 625 to 675, you're probably going to get the loan. A lot of them you have a cutoff at like depending on who you're dealing with, a 700 or 710. If you're above that, you're considered a good risk. The credit score generally determines what type of interest rate you're going to get. If you get the loan, if you have that credit score in the 600s, you're going to pay a higher interest rate than if you had that credit score in the 700s. You'll get a lower rate if you have a higher score. What generally determines whether you get the loan is whether the bank feels you have the ability, you have the income to repay that loan. And that is the debt to income ratio. Now, income is your gross pay. Like we talked about earlier, your 40 hours a week or whatever times your hourly rate. Yeah. Well, just because most people have a pretty much standard amount of taxes they're going to pay, they don't. The one thing they really, when they do that, the big thing they don't consider is if you have to pay a lot for health insurance and stuff like that out of your paycheck, and that's where you can get in trouble. Is if you do have a huge health insurance bill. But yeah, your taxes, the amount of taxes you pay is usually pretty standard, so that's kind of accounted for in the formula. Yeah. 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 And that's generally where people get in trouble with loans, where the most of the formulas for calculating loans go bad is if you have to pay a lot for insurance, or the other one is child support. Because child support isn't considered into that formula either, and that comes out after your gross pay. So it's not figured in, and that can get you in trouble. So your gross pay in this ratio is your gross pay for a month. So let's say that you are getting $3,000 a month as your gross pay. Your debt does not include gas, food, or anything. It is actually debt payments, loan payments. So let's say you have $100 a month for credit cards. School loans, let's say you're paying $200 a month for school loans. A car, how expensive of a car do you want to own? Well, when you buy it, you want $10,000 car, $15,000, $20,000, $30,000? So a $30,000 car will cost you about $600, depending on whether you go 5 years or 6 years. This would be a 5-year loan, it would cost you about $600 a month. A 6-year loan, that $30,000 car costs you about $450 to $500 a month. So $600 a month. We'll go down to $500 a month. We'll assume you stretch it out over 6 years. So $500 a month for car. You already have $800 per month in debt payments. So your debt to income ratio is $800 to $3,000. Both of those can be divided by $200. That is a 4 to 15 ratio. The debt to income ratio is actually usually it's a little weird. We want the numerator to be 1. So I'm just going to divide that by 4 on top here. This is a 1 to 3.75 ratio. We want this ratio to be less than 1 to 3. So we want the number on bottom to be 3 or larger. So right now, this is a good debt to income ratio. 1 to 3.75, that's better. That's below the 1 to 3 ratio that we want it to be. Yeah, and that's where my next step is. One to 3 is kind of the standard for your debt to income ratio. They want you to be at or below 1 to 3. You heard about the big mortgage crisis in 2007, 2008, 2009, where a lot of people defaulted on their loans and the huge, massive foreclosures on houses. That was because there was actually federal regulations that pushed lenders to push that up instead of a 1 to 3 to a 2 to 5 ratio. A 1 to 3 is 33%, 2 to 5 is 40%. So they're pushing people up to have larger and larger debt payments every month. So what it did is it put them on that edge where if their take-home pay decreased at all, they couldn't afford to make their payments anymore because they had that higher debt-to-income ratio. So now what they've done is they've pushed it back down. It's 1 to 3 is 33%. A lot of them do 35, 37%. Every bank's slightly different, but 1 to 3 is typical. So if you have $3,000 worth of income, that's only $1,000 worth of debt that you can have. 1,000 to 3,000 is a 1 to 3 debt to income ratio. So if you already have $800 in debt, how much do you have freed up to buy a house? $200 a month, right? If you have $800 a month in debt payments, your maximum is $1,000 a month, according to that 1 to 3 debt to income ratio. Now, if you bought a cheaper car, if you bought a $10,000 car and you only had a $200 a month payment, now that then increases your what's available for buying a house. A lot of people get in trouble this way because they can afford to buy that $30,000 or $40,000 car, but then 3 years down the road they want to buy a house. Well, their debt to income ratio is too high. They can't buy the house until they've paid off the car. They still have 3 or 4 years left on the car. I've actually seen cars now, well, trucks, financed for up to 8 years. You're looking at these $50,000 or $60,000 trucks. Okay, it is that time. So there's a new quiz that is due tomorrow, Thursday at 11:59 p.m. And a new homework due for Monday at class time. Tomorrow we'll talk a little bit more about these ratios and then some proportions that we use for calculating with these ratios. So I'll let you guys out of here. You have a good day. We'll see you tomorrow.